Hello everyone. In this recording I will talk about the NP charts. This is the last chart of the group. So the formula is just we have this one is the center line. If you remember, the NP was the number of non-conforming products. This is the center line for our case. You can say that average NP or average NP. And then here M is the number of the samples. The p-value, the average p, is that np divided by the n values. And then we have the upper control limit and then lower control limit. This is what we use for the NP chart. And this one is used for upper control and the lower control limit. And you can find the p-values this way. Or you can divide one by one and then find the p-values. Okay, so let's go to example. So we have the sample numbers 1 to 14. So as you can check, so M is 14. And then we randomly select the PCB samples for defects. So you can see we have the sample size of 80. So at each time we select 80 PCB board. So what it means is that each sample that contains 80 PCBs. And then the NP value is number of non-conforming products. Non-conforming products. And the question is that to plot the NP chart and explain the trend. Let's plot it and see what's going on in this chart. So these are the values that we have. So we have the same values as here. The first thing is that I need to find the average NP value. So that average NP bar is equal to the sum of the NP values, sum of these NP values divided by the 14, which is the number of the sample size. Okay, or you can add a new one here and say that M is 14, and you can say that N is 80. Sorry, N is 80. Okay, and instead of this one I can use A15, I can use this M, and then make it a $sign here, $sign here, and $sign here. Okay, and then this is the center line. Then we need the upper control, and also I need the p bar value. And the p bar value is that you can divide NP by N, 3 by 80, 2 by 80, and then find the average, or you can just sum them up and divide this sum. So what it means is that you will have the sum of these values here, then divided by the sum of these n values. This will be give you the p bar value. As I told you, you can also go this way, find p value. So it will be that np by the n value. Then you do for all of it, and then you take the average of it, average of these values. As you can see, you get the same value here. They are the same. Okay, so now let's find the upper control limit. The upper control limit will be the NP value, which is this one, plus the 3 times the square root of the NP value again, NP bar, sorry, times 1 minus the P bar value. Okay, and this one should be the F4 sign. Sorry, this one should be F4 sign. And then we have the F2 value, it's okay, and then F2 is okay. Let's look for it, and then we have it. This is the upper control limit. We have the lower control limit. This is the same formula and with the minus sign. So it will be that np bar minus 3 times the square root of np bar times 1 minus p bar value. This one should be with the dollar sign. P bar with the dollar sign. Okay. And then it is negative. So the rule is that if LCL for any case is less than 0, and then you set the value to 0. Okay. Since in this case it is negative, I will make all values as 0. Okay, now let's plot it. See how it looks like. So that insert, we will have the chart here. Then we will select the data. The data will be that we have the x values, which are the samples. The y values, we have the np values. Sorry, this one is the np values. Okay. And then we add it. We add the, again, y values, the upper control limit. And then we add the lower control limit for the y-axis. Okay. And then we are adding the center line. Center line is this one. Okay, and then let's see, let's make them as a solid line, the format, and then the solid line, and this one as solid line, and this one as solid line. Okay, so as you can see, so it is also in the control limit, so everything is in the control limit, but we have a simple problem here. So 1 2 3 4 5 6 7. So let's see, actually there is, it looks like there is a, let me just add it to our PowerPoint and then see how it looks like. Okay, and this one is the upper control limit, this one is lower control limit, and these are the np values. Okay, and then here it looks like there may be a trend, which is not good. Okay, so for any chart it must be random, it must be random points. So you can see it looks like there may be, well, you can see that maybe a trend. If there is a trend, it means that it is not a random, it means that there is something external cause. So let me add it here. So maybe not random. So not random means there is an external cause. What is that external cause? But these are all, you know, it has to be checked. Yes, maybe I'm adding maybe external cause. What example? Maybe the operator error, or it may be that new machine is there. Okay, so these points should be checked, that what is causing the problem for these defective units. Okay, that is what you have to check, and then eliminate the source, the errors, and then plot it again. So this is how the np chart works. Next presentations I will talk about the other charts that we have.